Welcome to lecture 6.6. So now we have something called the law of cosines. Okay, so for the law of cosines, this is if we're looking for a side on a triangle. So this is only for finding the sides on a triangle. And when we're doing this, please make sure that your calculator is in degrees. So the law of cosines. In a triangle, ABC, we have the following. So a squared equals b squared plus c squared minus 2bc cosine a. So it might look really complicated, which the end parts are a little harder to memorize, but you'll notice this comes pretty much from the Pythagorean theorem. We have the a squared, b squared, and c squared values. And then we just take the subtraction of the values that are already on this side. So notice we have the b and the c, bc, times 2, and then cosine of the angle you have. And notice that is going to be the angle that is directly across from the value you are trying to find. Or at least the main way you would use it. So let's take a look at some examples. For example 1, solve the triangles, write the angles in degrees. Okay, so we have this triangle here. What are we given? Well, we're given 2 sides and an angle. So this is going to be a side angle, side triangle. So this is not the strange case. This is the case that we know we can handle. They're not going to have too many answers on it. If there's one answer, it'll just be the one. So let's see, what else do we need to solve for? We need to solve for this angle, and then the side B. Well, let's go ahead and try out the law of cosines to see if we can find B. Well, our formula for a B value is right here. So we're going to use B squared equals the A value squared plus the C value squared minus 2AC cosine of B. Let's go ahead and highlight some corresponding values here. So the B is this value here. We're going to have to plug that in for cosine. And then we have our 26, which is going to be the little a, because it's across from A. And then our C value is 18, because it's across from the big C. Okay, so let's go ahead and plug these values in. We'll have B squared equals 26 squared plus 18 squared minus 2 times 18 times 26, and then cosine of 26 degrees. All right. Okay, so we plug those in. Let's go ahead and do some small calculating. B squared is going to equal 676 plus 324 minus 936 cosine of 26 degrees. And then, let's see, so adding those two values up together, we'll get B squared equals 1000 minus 936 cosine of 26 degrees. And then at this point, let's just go ahead, square root both sides, but we know we're only going to keep the positive, because once again, we're looking at the length of the side of a triangle, so it wouldn't make sense to have a negative. Okay, so those cancel out, and we are left with B equals the square root of plus or minus. Now, this is something that you're going to want to do in your calculator. I would not really write down, well, you could write down an approximated value inside the root for your work, but I would just take the square root of this in your calculator to get an approximate or better approximation. So we can approximately plus or minus 12.6. And if you need to know how to do a square root in your calculation, you just plug your answer in and then you write caret half power, or you could use the square root symbol. Okay, so B is approximately plus or minus negative 12.6, but we're going to take the positive. Okay, so we've basically solved all of the outside of the triangle. The only thing left we have to do is find the two inner angles. So how can we find the inner angles? Let's go ahead and use the law of cosines here. Because notice, we can play with the equations and find one of the other angles possibly, A or C, by using the formulas. So let's go ahead and do that. We're going to solve for either A or C. Let's go ahead and solve for C. So here I'm going to write solve for b on here. Little b. Once again, be careful of your capitals and lower cases, because they do really make difference here because we're using capital and lowercase b's and a's and c's. So let's do solve for, it's hard with c to tell a capital, but okay. So let's use c squared equals a squared plus b squared minus 2ab cosine of c. Now this time we're trying to solve for the angle c right there, which means we're solving for that value. So we'll plug in all of our other values. C is 18 equals, and then we have, let's see, 26 plus 12.6 squared minus 2 times 26 times 12.6, and then cosine of c, which is what we're solving for again. All right. Let's see. Plugging that into the calculator, we'll end up with 18 squared. And then we'll subtract over these two values here. So we'll get minus 26 squared minus 12.6 squared equals, now, skipping a small step, we'll go ahead and have cosine of c, and we have divided both sides by that negative 2 times the 26, 12.6 on both sides. Then we can plug that into our calculator, and we'll get that, let's see, 0.78 is approximately cosine of c. So how do we get the c outside? Right now it's inside cosine. So once again, this is where cosine inverse comes into play. So go ahead and take the cosine inverse of both sides, and we get cosine inverse of 0.78 is going to be approximately equal to capital C. And that value comes out to be about 38.8 degrees. Now we have almost everything. That's 38.8 about. Now we just need to find A. So to find A, we'll add up 38.8 and 26, and then subtract it from 180. So 180 minus 38.8 minus 26. Let me go ahead and write finding A. And then we get at 115.2 degrees. And there we go. We found A as well. Okay, so we were able to use the law of cosines to solve the triangle. Now let's go ahead and work on example, well, it's still example 1. Let's go ahead and work on the other triangle for example 1. Let me just draw this line down the center. Alright, so let's take a look at this next one. What are we given? Well, once again, this is a side angle side triangle because we have side, angle, side. And we're missing this side right across from this angle. So let's go ahead and use the law of cosines to try solve for that c value. And then let's follow the same path we did before for the first one. So I'll go ahead and say solve for c. And then we get c squared equals. So let me go ahead and write down which one we're using. We're using c squared equals a squared plus b squared minus 2ab cosine of c. Okay, so what are our values? Let's see. So 8 is a, b is 11, and then the cosine, capital cosine, is 37. Plugging those in. C squared equals, we have our 8 plus 11 minus 2 times 8 plus 11, or sorry, times 11, cosine of 37 degrees. So then c is going to equal, I'll go ahead and just do the plus or minus now, and you could go ahead and plug this into your calculator. Now this would be all the work I would expect to see for these ones. You don't need to do a bunch of all this mini calculating that I did here. As long as you show the formula, show the input of the values, and then you can do this one step here, and after that you can go ahead and just use your calculator, just so you don't get too many approximations in your work. Alright, so plugging that into the calculator, we'll get that c is approximately plus or minus 6.67, and we're going to go ahead and take the positive 6.67. Okay, so that's our C value. We have that. Now what are we missing? We have C is 6.67. We're just missing these other two angles here, A and B. Let's go ahead and use the same method we did before. So let's go ahead and find angle A. Find capital A. Okay, so the formula we're going to use to find A will be A squared equals C squared plus B squared minus 2CB cosine of A. Why are we using this formula? Well, once again, we're trying to find capital A, and the formula that includes capital A for cosine is the one that has A squared as what we're solving for. So let's plug in the values we have. We'll have, let's see, so 8 squared equals 6.64 squared minus 11 squared minus 2 times 6.64 times 11, and then cosine of A, which we're solving for. Okay, so once again, showing this step, showing the inputs, and then if you just calculate it out after this point, that's fine. So when we calculate that out after subtracting everything, we'll get 0.6916 is approximately cosine of A. Once again, these are the steps I would expect to see, because you can do this step here with your calculator. And then, so cosine inversing both sides. Once again, show this step, please. We have that A is approximately equal to cosine inverse of 0.6916. And then A is going to be approximately equal to 46.24 degrees. Okay, so we found almost everything except for the last angle for B, because A is 46.24 degrees. So to find B, just go ahead and use the fact that the inside degree should be equal to 180. So we'll take 180, subtract 37 from it, and subtract the 46.24. And we'll be left with, the inner angle is 96.76 degrees. So B is approximately 96.76 degrees. Okay, so we solved this triangle using law of cosines. Hopefully not too bad. There's a lot of small calculator work, but once again, you will be allowed to use your calculators for this. So let's take a look at example 2. A sailboat and a tugboat leave the dock at 6 a.m. Ooh, a word problem. The sailboat travels at 8 miles per hour, and the tugboat travels at 24 miles per hour. How far apart will the two boats be at 11 o'clock a.m.? So they've left a dock, and then they each travel out in different directions. So if this is the dock, this boat travels out that direction, and then, or that's the tugboat actually, and then this boat travels off in that direction. Sorry for the little application symbol there. Okay, so they've traveled off in those directions, and then what we're trying to figure out is how far apart they will be. So from here to here, we're trying to figure out this distance here. And they want to figure out how far apart they will be at 11 a.m. Well, that's great, except I don't even know how far apart these guys are from each end here. So what information do I have? Well, they left at 6 a.m., and we're trying to figure out how far apart they are at 11 a.m. So how many hours apart is that? 6, 7, 8, 9, 10, 11. Okay, so 5 hours apart. So 5 hours go by. And then we know the sailboat travels at 8 miles per hour, and the tugboat travels at 24 miles per hour. So this is a sailboat, and that's the tugboat. So in 1 hour, the sailboat would travel 8 miles. 2 hours, it would be 16, right? So after 5 hours, the sailboat would travel at 5 times 8 miles per hour, which is 40 miles. Oh, good, we found one edge, or one length of the leg. Now the tugboat, it travels at 24 miles per hour. So in 1 hour, it goes 24 miles. 2 hours, that's 48. And then in 5 miles, that's going to be 24 times 5, which would be 120 miles. Hey, look at that. So we found, we're slowly filling out our triangle here. Now the only thing we need is this side here. And the question is, do we have enough information to figure that out. Let's see, we're told the law of cosines, and with the law of cosines, if you're missing a side, you just need the other sides and the angle across from the side you're missing, and you're golden. Do we have that? The answer is yes, we do. So we have what it takes to use the law of cosines. So we're going to go ahead and use that. We're looking for the value I've called a. So we have that a squared. We're going to use a squared equals b squared plus c squared minus 2cb, or bc, cosine of a. So a squared, which is what we're looking for, equals our b value. And, it doesn't matter which one we assign as b or c, but I'll just go ahead and assign b as the sailboat's distance and c as the tugboat's distance. Why does it not matter? Because we're squaring both of them, and then we're just multiplying the two right to each other. So it doesn't end up mattering for this problem. Or, sorry, for this equation. Alright, so plugging that in, and we get a squared equals, if you want to go ahead and do some fun with the algebra, you can. If not, you could have just gone ahead and plugged that into your calculator. Oh, sorry, I forgot to plug in cosine of 120 here. Alright, and then, so a is going to equal this plus or minus the square root of 16,000 minus 9600 cosine of 120 degrees. I keep making that square root a little too short for the problem. Okay, so after we do that, plugging that into your calculator, you're going to get that a is approximately equal to 144.22 miles. Still plus or minus, and we're going to take the positive. So that's the distance. So the distance between the sailboat and the tugboat is 144.22 miles after 5 hours. Alright, so now we're looking at something a little different. This is called heading and bearing. This has to do with navigation, like if you're looking at a compass. So in navigation, heading is the direction the craft is pointing, and bearing, which makes sense, right? Because if you're heading in a direction, that's the way you're going, or that's the way, like, your face is pointing, right? And bearing is the acute angle measured from due north or due south, which represents the direction of the craft. Where craft means the object heading in that direction, whether it be a plane or a boat or something else. Okay, so let's take another look at what this is. So if I was saying something was heading due north, that means it is going up in the northward direction. If I said something is heading due south, that means it is heading down in what I would say the southward direction. And then from those angles, we'll get either a direction west or east. So for example, if I said south and then some angle east, I would go that angle in the direction of east. How many degrees that way? And that is where my object would be. And so on like that. So, if I was an object going north and then west, that would be called northwest. An object going north, east is northeast, and so on. And we have southeast, southwest, northwest, and so on. Alright, so graph the following directions. Okay, so I'm just going to go ahead and write down my main compass values. So I know I have north, south, west, and east. If you're ever confused on west and east, as my sister once taught me when I was a kid, it spells out the word we, W-E. Okay, so we travel. Alright, now let's see. So we want to go north. This is the first thing we're thinking of. Okay, so I know I'm going to go up north. And then what happens? And then we're going to go 40 degrees west. Now this is just a sketch, so it doesn't need to be perfect. But we know we're going to head the direction west. How far? Well, 40 degrees. So trying to keep with a pretty realistic graph, we'll go ahead and go about here. So that is the angle we have, and this is roughly 40 degrees. Alright, now let's do the next one. South, 70 degrees east. Okay, so first off, we know they're going to be heading south, so let me get my graph drawn in. We got and then north, south. Okay, so we're heading south first. And then what happens? We're going 70 degrees towards the east. So that's actually quite a bit farther than before. So 70 degrees east. 70 degrees. And here we go. Pretty straightforward. So now let's take a look at this problem. Example 4. A pilot leaves an airport and heads in the direction north 20 degrees west at a speed of 200 miles per hour. After 1 hour, the pilot changes course and heads in the direction north 50 degrees west. 2 hours later, he lands the plane. So part A, find the distance from the airport to his final landing point. And then B, find the bearing from the airport to his final landing point. Okay, so let's go ahead and draw an image of this first off. Alright, so he leaves an airport. Let's say that this right here would be A for the airport. Let me change that color, A. And then what do we know? Heads in a direction north 20 degrees west. So if I went ahead and I drew this, so my normal bearing. So it goes north and then 20 degrees west. So north and 20 degrees west, so it's a small angle change there, 20 degrees west. And then what happens? After 1 hour, the pilot changes course and heads in the direction north 50 degrees west. Okay, so at this point here, changes direction and heads. This is north, south, west and east. It stops, changes north 50 degrees west. It's a little further, north 50 degrees west. 2 hours later, he lands the plane. Okay, what are we looking for? We want to find the distance from the airport to his final landing point. So, if this is his final landing point, let me actually extend this arrow a little bit. We don't really know how far he traveled, but he traveled some distance. So if that's his landing point, and the airport is down there, we are looking for this distance here. And notice, if I had drawn that line correctly, it would create a triangle. So let me go ahead and draw this triangle a little better with the angles that we have. So if we have a triangle here, I'm just going to draw it a little bigger so I can fit in all of my drawings. It will probably not be perfectly accurate. Once again, these are just sketches. Okay, so this value, or this corner there, is the airport. This corner here is the landing point, just copying off of this graph here. And then what do we know about here? Well, let me go ahead and zoom in a little bit. So we know that right here, that this angle here is supposed to be 50 degrees. Once again, it's not perfectly based off of our information. And then this angle here, that we create here, is supposed to be 20 degrees. Alright, so now what else do we know? What are we looking for? Well, in order to find out this distance here, and we're in the Law of Cosines section now, so I'm going to hope to try for some Law of Cosines. I want to figure this out here. So to figure this length out, I would need to know this angle, as well as this length and this length, in order to use Law of Cosines. So let's say I called this angle here, for that one right there, let's say I called this C, big C. That'll be little c. This will be little a, and the other one across from it will be little l. I'll call it scripted L. So if I was doing this, I want the formula c squared equals, and in this case it's going to be a squared plus l squared minus 2al cosine of big C. And what are we trying to find? Well, we're trying to find the highlighted blue, so we're trying to find C. And currently, we don't have any of the information we need to solve. Shucks. So how do we figure that out? Well, we are given speeds in terms of miles per hour. And we're told the time it takes in each direction. So we know that when he first heads out, he's heading at 200 miles per hour, and he changes direction after 1 hour. So this distance here, L, That was only 1 hour. And in 1 hour, he goes 200 miles. So L is going to be 200. And then the distance here, which we called A, he traveled for 2 hours. So in 2 hours, how far will he have traveled? 400. Once again, the graph is not to scale. All right, so we found A and L. Awesome. Let me highlight those. So that's my, oops, wrong highlight. A and then L. I did what? Red. So I found A and L. Next thing I need to do is to find out capital C. So I need that angle. How do I figure out that angle? I'm not given it. I'm only given 50 degrees, which is above it, and then 20 degrees, which is below it. Well, now this is where we're going to be a little sneaky using some rules for angles. So if we had some angles, let me go ahead and write it here in green. If we had two angles and it was bisected by some line, this angle here is going to be the same as this angle down here. So with that, we have these two lines here, and we have this bisecting line here, or intersecting, which means that this 20-degree angle will have an exact matching 20-degree angle right here. So I know that that is also 20 degrees right there. If you can see that, I hope you can see that. That is 20 degrees. Okay, so now I only have two more left. I have to figure out this slice and this slice. Well, this slice, I know what that is. That's a whole quadrant piece right there. That's going to be 90 degrees. So that'll be 90 degrees. Last thing to do is figure out this slice right here. Well, I know this total slice is supposed to be 90, and I know part of it, 50. So 90 minus 50 is going to give me the other part, which is 40 degrees. Okay, so I figured out the three slices of the pie for my degree. I got 20 degrees, then I got the 90 degrees, and then I got the 40 degrees. So the total degree of my angle here comes out to be 40 plus 90 plus 20, which is 150 degrees. Actually, let me write that in black. Okay, that took some finagling. Alright, so that angle there is 150. Let's go ahead and plug that in. So angle C is 150. Alright. Then I have C squared equals, and our A squared was 400, plus L, which is 200, square that, minus 2 times A, which is 400, times L, 200, cosine of C, which is 150. And then that means that C is going to equal plus or minus the square root of 400 squared plus 200 squared minus 2 times 400, 900, oh sorry, that's 200, cosine of 150 degrees. Okay, so plugging that into your calculator, you'll get that C is approximately 582. Or plus or minus, and then we take the positive 582. So what is the answer there? The answer is the distance from the airport to his landing point is, let's see, 582 miles. Okay, alright, so we did that. Let's take a look. The next part, part B. Part B, find the bearing from the airport to his final landing point. Okay, so this is interesting. What direction is the plane heading? Well, we know from the starting point, he's going north, right? So I know in the beginning, for B, I'm going to have writing north. And then, I know to get to there, if I go up north, I'm heading this direction, so that direction is west, right? So I know it's going to be northwest something, but I need to find the degree it travels in that direction from the original north position. How will we do that? Well, I slightly covered it up, but we do know a portion of our angle. Let me go ahead and zoom in on this. I did cover it up. Okay, so we know that this angle here, originally was told to us, was 20 degrees. And we are trying to figure out this whole distance. So this whole distance would be whatever this angle here is whatever this little sector here is, plus 20. Add those two together and we get the total distance traveled from north. The question is, how to figure that out? Well, that is going to be what we called angle A. So we need to figure out angle A. All right, let's go ahead and do that with law of cosines. So to find A, let's see, well, we know A, little case a, or lowercase a, so we're going to use a squared equals, and we're using the different names for sides here. We have L squared plus C squared minus 2LC cosine of, and we're trying to find A, so big A. Once again, the angle we're trying to find, let me pick a different color here, is this angle right there for A. Okay, so we're trying to find that. What do we have, though? We have L, which is, oops, let me change the color. L is 200. And then C, we figured it out, was 582. And A was 400. Okay, let's go ahead and plug in those values and solve. So A is 400 squared equals L squared, which we had was 200, plus C squared is 582. We found that out from part A. Minus 2 times 200, 582, cosine of A, which is what we're solving for. Okay. So that'll come out to be about 16, 1, 2, 3, 4 equals. Combining those all together, we get 378,724 minus 232,800 cosine of A. Alright, subtracting this over and then dividing both sides by this value here, we get 0.94 is approximately equal to cosine of C. Sorry, cosine of A. Alrighty, how do we solve for the A value inside cosine? We're going to go ahead and use cosine inverse. So go ahead, cosine inverse both sides. And then we get cosine inverse of 0.94. It's approximately equal to A. And then, plugging that into the calculator, make sure you're in degrees, we get 19.75 degrees. It's approximately equal to A. Alright. Now, when you're talking in bearings, most of the time we're going to go ahead and use whole numbers, so rounding that up, we get 20 degrees is approximately A. And that was the value here, this little section right there. So to figure out the whole section, this whole section piece that we're looking for, sorry, there's so many colors going on here. To figure out this whole section piece, we're going to add the A value to 20, add those up, and we'll get the whole pie slice that we're looking for. So, to find the degree, add 20 degrees plus the 20 degrees. This is the 20 degrees from A, and then the 20 degrees that we already knew earlier, and that gives us 40 degrees. So we're going to go north 40 degrees west. Let me go ahead and write that in a sentence. The question is, find the bearing. The bearing is north 40 degrees west. Alright, a lot of the times it was being tricky with knowing angles to find other angles. That was definitely part of the trick. Okay, so changing gears a little bit, here we have something called Heron's formula. And Heron was a Greek guy way back in AD 62 in Alexandria in Egypt, and basically was studying all these things. He liked geometry and inventing things, and he figured out this formula. And what is the formula? The formula is that the area of a triangle is given by this. You take the square root of s times s minus a times s minus b times s minus c. What is s? Well, where s is half of a plus b plus c, of the semi-perimeter of the triangle. That is, what does that mean? S is half the length of the perimeter. And what is the perimeter? The perimeter is the whole outside area. Once again, if somebody said something, check the perimeter of the base. Perimeter is the outside area. So the S in our formula is if you add up all those values and divide it by half, that's what the S value is. So let's go ahead and find the area of the triangle using Heron's formula. So A, I'm going to go ahead and give a slight scripted A there, is going to equal square root of S times S minus A times S minus B times S minus C. First off, let's go ahead and highlight those values. So I'll go ahead, and this value would be our lowercase c because it's across from C. This value here would be lowercase b, and then the value here would be lowercase a. Okay, so first we need to find S. S is going to equal half of A, so that'll be 40 plus, basically it's all of the sides, 24 plus 32. So then S is going to equal half of all of that, which is 48. So S is 48. Plugging this into the formula, we have 48 times 48 minus A, which was 40, times 48 minus B, which is 24. And then 48 times, or sorry, not times, 48 minus 32. Okay, so we've got all those values. We go ahead and fix my square root sign, and then you could plug that into your calculator, and you get that A is equal to approximately 384, and we would say meters squared because we were given a unit, so be careful with that. Meters squared. Now, example 6, find the area of the figure. Alright, well, we have a formula for finding area, right? A is going to equal, we have the square root of our S side times S minus whatever A is, S minus whatever B is, and S minus whatever C is. But I don't just want the area of one triangle, right? I want the area of two triangles. And to find that, I could go ahead, if I found the area of this triangle, I'll call the, I don't know what bluish color that is, and then I added that to the area of this triangle, I would have the whole figure, right? So to find the areas of all these triangles, I need all of the sides, because that's what my formula requires. Now I know most of the sides. I got this side and this side, and then this one and this one. The only side I'm missing for both of them is this one right in the middle, and I really need that side to fill out my formula. Does that sound familiar? We have two sides and, an angle, and we need to find one side. That should bring into mind the law of cosines. That's when you have, or you're given, a side, an angle, and a side, and you need to find the other one. Let's go ahead and use the law of cosines to find this side. And I'll call this one C. So finding C. So to find C using law of cosines, we'll have C squared equals, and then we want the A squared and B squared, which it really doesn't matter which one I pick for A and B. I'll just go ahead and use 5 as the B value, plus the 12 as the C. Then we'll do minus 2 times the two leg values, and cosine of our angle, which is 90 degrees. And then just following the formula, square root of, I'll just go ahead and write 25, why not, plus 12 squared minus 2 times 5 times 12, cosine of 90 degrees. And then after we plug that into our calculator, we get that C is approximately plus or minus, a nice number. It's actually not approximately, it's an exact number. It's going to be equal 13. And you could probably have just found that using the regular Pythagorean theorem, but I went ahead and used the law of cosines. So we'll take C equal to positive 13 because, once again, it is a triangle. So we have positive lengths. Alright, so we figured that out. So now let's just go ahead and figure out the area of the two different figures. Okay, so I'm going to go ahead and call blue area blue. So blue triangle. So to find the blue triangle, I need to figure out S for the blue triangle. So S is going to equal half of all the sides, which will be 9 plus 8 plus 13, and S is going to equal 15. So then A is going to equal the square root of 15 times 15 minus 9 times 15 minus 8 times 15 minus 13. Okay, so then A is going to be approximately equal to 35.49. Okay, so that's the first area for the blue triangle. And then let's go ahead and find the other area. So let me do that, area of blue triangle. And let's go ahead and find the area of green triangle. Okay, area of the green triangle, let's go ahead and find S. S is going to equal half of all the areas, or the sides added together, so that's 12 plus 5 plus 13. So S is going to equal the same thing, which is going to be 15, which means our calculation will pretty much end up coming out to the same number. So that'll be the square root of 15 times 15 minus the sides, so 12, 15 minus 5, and then 15 minus 13. And we get the answer of A is going to actually equal the exact answer of 30. So we have the two areas. A, I'm just going to call this B, area of blue, area of green. Alright, so adding them together, we're going to have, so AB plus AG, the two areas together is going to be 35.49 plus 30, so that'll be 65.49. Then our answer would be, area is 65.49, right there. Alright, and that is it for section 6.6. Please email me if you need help going over any of the examples or if you would like help with any of the homework problems.